Hello everyone. We are starting a free open lecture on our Discord. If you are a viewer and want to ask questions and get answers in an online format, join our lectures. You can find the link to Discord in our Telegram channel. So today we will talk about selection sort. Selection sort is a sorting algorithm where, at each step, the array is gradually sorted by finding the minimum in the segment after the current index, but we use it in computer science programming for data sorting. Here, the purpose of sorting is standard for everyone. Let's go over this point again. At each step-by-step, the array is gradually and systematically sorted by finding the minimum in the segment after the current index. This definition applies to the classic selection sort, which sorts in ascending order. When sorting in ascending order, we take the minimum. If we are sorting in descending order, we will obviously take the maximum because the maximum should come first. Accordingly, the purpose and step-by-step algorithm. In the earlier case, we have an array size of 8 and the exact same array, 6, 5, 3, 1, 8, 7, 2, 4. Accordingly, we have an index I that is set, meaning initially it will iterate like this through each array. So if we look at the pointers I, these indices, we start with the 6s, then the 5s, then the 3s, for example, 6s, 8s, and so on. Here, the initial array is simply placed again, meaning if you look at it this way, it just shifts by 1 constantly. And accordingly, on the array after that, on this segment, roughly speaking, we find the minimum and place it at the beginning, approximately. At the same time, we can't just set the initial minimum value to something like 9,999,999. For example, when looking for the minimum, why? Because what if we potentially have a billionth element in the array? We can't possibly know that at all. But we can take the value at this index as the initial element. Thus, if we don't have an element smaller than the one at this index, we will swap it with itself. In other words, nothing will change. If there is, then accordingly we will find the minimum here, like in this case the 1, and it will take the place of the 6, and the 6 will take the place of the 1. This can be seen in the first step. That is, we are standing on the 6, which is the initial value. So we keep going, passing through this segment, finding the 1 here, and then we swap them because 1 is just the minimum value. Accordingly, it is important to understand here that we are not changing the values themselves, so to speak. We are remembering them because otherwise we wouldn't know at which index the minimum is located, because if we simply replace the 6 with a 1, the 1 will remain here, and we can't place the 6 instead of it. Therefore, we need to remember the indices but change their values. This is very important. Accordingly, we move to the second step. That is, we swap the 1 with the 6 here. Now we start from the next index, that is, nature, from the first one, since we have already placed the 1 at the 0 index. We find the minimum in this subsegment, which is the 2.
Want to become a great programmer? Subscribe to our Telegram channel.
We show that this is a 2 and swap the 2 with the 5. Next comes the 3. Here we found the minimum, which is 3, and 3 swapped with itself. That is, these two indices will remain in the same place. Accordingly, they swap with themselves. But it is still an operation. That is, even swapping in the same place is still considered an operation. Accordingly, 6. The next index is 3, so we move to 6, find the minimum, which is 4, and swap 4 and 6. Then we move to 8, find the minimum here. Yes, it is 5. So the minimum was here, a 5 is here, and an 8 is here. Then they actually swap places, and we get a 5 here and an 8 here. Accordingly, we move on. For the 7s, the minimum is 6, so we swap 6 and 7. Next, for the 8s, the minimum is 7, so we swap them. And that's it. The last element has no one to swap with. So our index runs from the 0 index to the second to last one. We go up to the second to last element, because to swap any place we need 2 values, and if there's only 1, there's no point in swapping or searching. In this case, it will just take the minimum as itself, but there will be no point in that. Why should we perform an unnecessary operation of swapping with itself? If we start with this, the minimum will also be here, and it will swap with itself. Algorithm complexity is O(n) squared in best and O(n) squared in the worst case. Compared to the previous sorting, you can watch the previous video on the previous sorting. It also works in the worst case in O(n) squared, but in the best case, it works in O(n), that is, in O(n) under certain conditions. The video explained under which conditions it works. Accordingly, we have the pseudocode. For selection sort, in the selection sort function, we send the given amount of data, or vice versa, n then r. We send these n then r in any order. Accordingly, we have the index of number 1, which is the index, and in the range from 0 to the amount of data minus 1. This is because there is no point in taking the last element. It will swap with itself. And accordingly, the index of the minimum value is to remember the original index of the minimum, the index of number 1, that is the initial value where the index I stands, for the index of the number 2 in the range from the index of the number 1 plus 1 to the amount of data. That is, we will go from index I plus 1 to the end. That is exactly on this segment why we do not take the index of the number 1 initially, but it is already saved as the minimum index. So again, there is no point in taking it every time, because then it would compare with itself, which doesn't make sense. If the data at index 2 is less than the data at the index of the minimum value, then we overwrite the index of the minimum value. That is, if we find a number that is smaller, we overwrite the index of that number. And accordingly, after this loop is executed, yes, this is most likely better. At this level, we perform the swap. We swap the data at index 1 with the data at the minimum index. What does this mean? It means that we swap the data at index I, as stated in the algorithm. So this is the index and the index of the minimum value. These are the ones, it says we will swap them. Accordingly, the returned data is an array, and you can see the code in Python. That is, we have a selection sort array. In this case, a list is simply passed. Here, there is some interpretation of this algorithm, meaning the essence does not change, only the implementation does. So, we have selection sort, an array is passed to it, we have I, which moves through the length of the array, len of array. If someone doesn't know Python, this is the length of the array, that is its size minus 1, because there is no point in taking the last element. The minimum x equals I. For k in range from I plus 1 to the length of the array, here k is like our I. Accordingly, if array k is less than array minimum index, then the minimum index equals k. This is where the overriding happens. Then, after this loop, the index 1, the value at index y, and the value at the minimum index are swapped. In this case, in Python, it can be written like this. It works like the swap in C++. Accordingly, the data is returned after all the 4 loops. Here is the code in C++. We have some cell sort, which is a shortened form of selection sort, and accordingly we have R in size. We pass I here, it moves up to size minus 1, min I is equal to I, then j goes from I plus 1 to size, and each time it increases by 1. If R at index j is less than R at index min I, then min I equals j, and so if they are not equal to each other, then a swap occurs. In this case, a swap was added to avoid swapping an element with itself, specifically the minimum I and I. And in this case, the array is not returned. Why is it not returned? Because it does not work directly with the array. Oh, that's why it is not returned here. Basically, that's all. Thank you for the lecture. Join us for our next lectures. They take place on Tuesdays at 10 a.m. Thank you for your attention.
Want to become a great programmer? Subscribe to our Telegram channel.